Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Azmi bin Musa, metric number 01DKA21F1091. Today, me and my group will present about fieldwork 3 about a setting out. Okay, before that, I will introduce my group of members. Firstly, Muhammad Azri bin Muhammad Azmi. Second, Shoba Rao anak lelaki Wiswa Rao. And lastly, Amsyara Asfa bin Nur Shaini. Okay, now I will continue with my part, which is introduction. Setting out is the process of surveying where the position and levels of buildings, roads, drainages, stairways, and all other engineering projects are already marked on a plan are transferred to the ground by a variety of methods and by specifically manufacture instrument, or is the process by which information is taken from construction design drawings and then pads, profile or other marks are set to control the construction work and to ensure that each element is constructed in the right position and to the correct level. Setting out is simply the physical transfer of plan into the ground. Setting out can be complex yet simple. For more accurate transfer, some engineers use the service of land surveyors to get their setting out right, especially in large projects. Setting out is the process of transferring the plan on paper to the actual ground or site of construction. A building is set out in order to clearly define the outline of the excavation and the line of the walls, so that construction can be carried exactly according to the plan. The centerline method of setting out is generally preferred and adopted.
My name is Amsyara bin Shaini and my metric number is 01DKA21F1075. Now I will present the equipment that used in setting up. The first equipment is the theodolite. Theodolite is an instrument used in surveying to measurement horizontal and vertical angle. It is also used for leveling, indirect measure of distance and prolonging a line. The second equipment is leveling equipment and stuff. The instrument and stuff are used to gather and or transfer elevation level during site survey. Measurement generally start from the benchmark with no height determined by a previous survey or an arbitrary point with an assumed height. The third equipment is measuring tape. It is used for high precision work in surveying such as baseline measurement, triangular survey, measure horizontal, vertical and slope distance. And the last equipment is plumb box. It is used while measuring distance on sloping ground and transfer the point to the ground by suspending the plumb box.
Okay, Bismillahirrahmanirrahim. Hi, Assalamualaikum. My name is Muhammad Azri bin Mat Azmi and my matrix number is 01DKA21F1083. Okay, today I will give an explanation on how to calculate the data collection. In this table, the base side, intermediate side and foreside are the readings taken in the field, and in the remarks column, benchmark and change point are specified. Then, with the help of the available data, the height of the instrument and the widget level are calculated and the user check are carried out. To begin with, the elevation of the plane of combination of the first instrument station is to be calculated. Okay, this is done by adding the backside to the reduced level of the benchmark. The reduced level to benchmark, i.e. point is taken as 95.00 and backside is taken by holding a staff at point is 0.520. Okay, elevation of the plane of collimation is 95.00 plus 0.520 equal to 95.520. These integral as the height of collimation or C are seen in the table. Then from the same instrument station readings are taken of the staff are integrated as the intermediate side. Then the resistance of a two are calculated. Okay, for example, RL of A equal to half of collimation minus intermediate side, which is 95.520 minus 1.120 equal to 94.400. Now the instrument is shifted to the next point and the backside and foresight are taken, then the HOC are reduced level at this point is calculated. RL equal HOC at first point and minus Fs, which is 95.520 minus 2.01010 equal to 93.510. Okay, then HOC equal RF plus BS, which is 93.510 plus 2.80, plus 2.810 equal to 96.3320. This procedure is followed till the last one is reached. Now the tests are carried out to ascertain the correctness of the regions, i.e. BS minus Fs equal to less Rl minus first Rl. So we are given BS equal to 3.33, Fs equal to 3.33, and the first Rl equal to 95.00 and the last Rl equal to 95.00. So 3.33 minus 3.33, the answer is 0. Okay, so the last RA, which is the 95.00 minus the first RA, which is the 95.00, equal to 0, and check. Okay, that's all from me. Thank you.
Good morning, Miss. I'm Shoman Rasanavisara, and today I'm gonna explain about analytics in this setting out. Okay, in the question, it's already given that gradient is 1:120. Culvert distance from A to E is 80 meter. Traveler level is 2.5 meter. Okay, to find the side rail A, what I did was invert level A plus width in traveler level, which is 92.685 plus width 2.5, and I got 95.185 meter. Okay, for the height of side rail A, what I did was 95.185 minus width 94.4, and I got 0.785 meter. To get inverted level B, I use the formula, which is invert level A minus invert level B over 20 equals to the ratio, which is 1/120. And over here you can see from this 20 I brought to the next side and I times with 1/120, and I got 0.167. So the equation goes with 92.685 minus invert level B equals to 0.167, and invert level B is 92.518. To get the side rail B, I used 92.518 plus 2.5, which I got 95.018 meter. Height of side rail B is 95.018 minus 94.305, and I got 0.713 meter. For invert level C, I use the same formula, which is invert level A minus invert level C over 40 equals to 1/120. And this 40 I brought there and I got 0.333. And to get invert level C, I invert level A minus with 0.333, which I got 92.352 meter. Side rail C, which is 92.352 plus 2.5, which is 94.852. Height of side rail C is 94.852 minus 93.862, and I got 0.99 meter. And the final one, which is invert level D, the same formula, invert level A minus invert level D over 60 equals with 1/120. Okay, and then 92.685, which is invert level A minus invert level D equals to 0.5, and which I brought 60 over there and I got 0.5, and the invert level D is 92.185 meter. Side rail D is 92.185 plus 2.5, which is 94.685 meter. Height of side rail D is 94.685 minus 93.685, which is 1 meter. Okay, that's all from me today. Thank you.
In conclusion, make sure that the corners have been checked by redoing the 3-4-5 rule on each corner and also checking the diagonals, of which it has a very large slight difference within a millimeter of a meter. However, any triangle with sides of 3, 4 and 5 units will have 90-degree angle opposite to the 5 unit side. The beauty simplicity of the technique are that if the engineer or builder needs increase the accuracy on larger walls or structures, any multiple of the 3, 4, 5 rule can be deployed, that is 6, 8, 10 or 9, 12 and 15 and 15, 20 and 25. All setting out pads should be outside the excavation area and shall relate to the first lines of brickwork of reinforced concrete frame buildings. The activity has achieved its aim. As student, I have acquired the knowledge in getting the setting out done. That's all from me. Thank you.
Okay, for the effectiveness of team. First is Azmil, he did introduction and conclusion. Next is Amsharul Asfa, he did equipments. And then Azri, he did data collection. And me myself, Shoban, I did data analysis and effectiveness of team. Okay, thank you.